Hey, okay, so I'm gonna propagate backwards in this video, and I already explained how we're gonna do that in the last one. So just make a function backwards propagate. Um, what's it called? And then we're just gonna say m is equal to x shape, right? And the reason for that is because, and actually, let me put x here so I can take x as an argument. And the reasoning behind this is because to compute the derivative to compute the derivative of our weights and biases, we need to multiply by the average of our data set, right? So that's why we're doing that here. And actually, go ahead and take parameters as an argument also. Let me put another space here. And then we're going to say W1 is equal to, we're going to access parameters and we're going to get W1. And I'm just going to copy paste this 4 more times and I'll just change the names so we don't have to keep going back and forth. Hope this is right. Okay. So let me explain what's going to happen here. So we're going to initialize our parameters. Then we're going to pass those parameters into forward propagation. Then we're going to retrieve A2 out of forward propagation. And we're going to pass that into cost. And then cost is going to return cost, right? Whatever. Now to backward propagate, we obviously need our parameters, which we're going to retrieve from params or initialized parameters. We're going to retrieve from initialized parameters, right? And we're gonna retrieve those. And actually, we don't really need our biases, so you can just get rid of that. Jesus, okay. So you can just get rid of that. So if you remember from my video, dz2 is actually just equal to a2 minus y, and if you guessed right, we're gonna also take what's it called? We're gonna actually, no, we're not. No, we're not. Forget about that. We're not doing that. So we need a way to access the cache from forward propagation, and you know what? I guess we'll just, for the meantime, we'll take a2 as argument, right? I'll fix it if it's not good, but basically it's just a2 minus y. So our y hat, the derivative of our y hat is equal to a2 minus y. Now the derivative of W2, and I also covered this, is going to be numpy multiply. It's going to be 1 over m times the natural, or not the natural, why do I keep saying that? The dot product of our derivative of z2 and our a1. And we're going to take the transpose of that. And for the meantime, I'll take a1 as an argument. If I'm going to change this, I'll change it and I'll show what I changed. So this is our derivative of 2, or our second weight, and the derivative of our bias is obviously just going to be the sum, and actually it's going to be numpy multiply 1 over m, and I keep forgetting to do a second parentheses, right? It's going to be 1 over m times the sum of all of our derivative of z2's, right? And if you're confused on the numpy multiply, it's just literally, it's like this. It's like the equivalent of doing this. So if you're confused on, that's what we're doing. And then to go more backwards, derivative of z1 is going to equal to, and I covered this also in the other video, so it's going to be 1, or it's not going to be 1 over, I'm sorry. It's just going to be the dot product of our W2 transpose by the derivative of our Z2, and yeah, I have no idea why I put capital W there. It's going to be that. So we're multiplying the dot product of we're multiplying the dot product of this times times the inverse function of our activation function, which for us was tan h, right? So a1 and 2. So this is just the inverse of our first activation function, or tan h, right? So just the inverse of our tan h function, right? Let me space this out a little so it looks less in the way. And again, I hope you're developing an intuition for this. The derivative of our first weight is just going to be numpy multiply 1 over m, and again, I forgot the parentheses there. It's going to be 1 over m by the dot product of our derivative of z1s and our x transpose. And derivative of, again, if there's something wrong, I'll fix it. And the derivative of our derivative of b is just going to be, and I forgot again, it's just going to be 1 over m times, obviously, the sum of all over derivative of z1s. And then we're just going to say cash is equal to, and we're only going to need some of these. Like, we're going to need derivative of w1 because we're obviously going to optimize derivative of w1. So derivative of w1, and similarly with derivative of b1. Oh, wait, yeah. So we're always going to need derivative of b1. And we're going to need derivative of w2. Because these are all going to be optimized, right? And then derivative of b2. There you go. I'm just going to return my cache. And everything should be fine here. Oh, and that's a massive error. I'm sorry. So here we want to say axis is equal to 1 and keep dims is equal to true. Because what numpy sum does is it does the sum on the entire array or the entire vector. And basically why that's bad is because we want to just sum up our rows, not our columns. And also it also changes the shape of our vector. So keep dims prevents it from changing its shape, if that makes sense.